So the second part is to calculate the z-score. So let me quickly give you a what a z-score is now, and where it is used. Okay. Z-score normally determines, let's say you have a sample of values, let's say any any sample of values, let's say values of on a certain day's temperature collected on an hourly basis. Now you have a 24 values. Now for these 24 values, we call it a sample data, and there is a mean that you can calculate from it, average value. And the z-score is something that tells you, hey, of all these 24 values, if we take a certain value, how much is it, how far is that value from the mean of all these 24 values. So that's what the z-score will give you. So, and it will represent that deviation from the mean value in terms of standard deviation. Hey, this value that you have selected is 3 standard deviations from the mean value. And likewise sorry for that. Yeah, so and it would normally mean if a z-score is 0, that means the value that you are looking for is identical to the mean value of all the samples. And if it's 1, z-score is 1, it would indicate, hey, the value that you are looking at is at 1 standard deviation away from the mean value that you're looking at. It can be both positive and negative. So positive values means it's just the value that you're looking at is greater than the mean value, and if it's negative, it means that the value that you're looking at is less than the mean value. Well, let's see. In Tableau, normally we don't have any functions to get the z-score value. We have to just create some roundabout calculation to get the z-score, but it's a straight slightly simple approach itself. We'll see how to get that. So I have some new data set here, which is called cars sales data. So let's quickly see the fields which are more relevant for this particular exercise. So we have state, country, and city, and we have a field called make, so which basically is the name of the car company. Okay, different car companies, and we have a field that is color, so which basically gives us what color is it, what type of colors each company would sell. So I think these two would be enough for the time being to get this exercise. And there's a for each under each of those cars we have a model as well. So we have a company, color, and under that color how many models are there, car model, and we have sales price field. Now what I'll do is I'll just try and let me create the visualization and see what question I'm trying to answer. So I have my sales, I have my color across all the companies, and I'll just bring my sale price to columns. Okay, and get my company name into detail. Let me just change this to okay. So what now it's trying to do here is, so what it's trying to tell me here is, hey, in the color, this particular aquamarine color, let me change this to maybe average, so that it will be nice. Yeah. So in this particular aquamarine color, so what are the average prices for each of the company cars? So for example, this one, aquamarine, in this particular whatever that company name is, the average sales price for a car is $25,000. So, and likewise for all of this. Now what I'm trying to get at is, we would like to see how each car company is varying from the average value of sales in that particular color. So let's say, for example, we know that if we see this particular section alone, so these are the sample values of average prices in this particular color. We definitely know average would lie somewhere around here, but this particular car company is selling way below the average price, and this particular car company is selling, Aston Martin is selling way above the average price. So let's see how we can let's quickly what I'll do is, let me get the average line and place it here. Instead of that, let me get it for cell. So okay, so yeah, so if you see, this is the average line, whatever the line that we see here, and based on that we need to calculate the deviation. So for especially this, for each of the color, we are trying to calculate how far is this point from this average. So that's what the z-score will represent, and we will create a calculation to get the same. So we create a calculation, call it z-score, and so it's based on the same logic that we discussed. Now we will create a calculation. So first we will get the average of sales price, and okay, let me first write the calculation and I'll explain. Window average.
I think there's a bracket after that average. Yeah.
Yes. Yeah. And then get the window deviation of average. So yeah, so this is the calculation. We have a numerator and a denominator. In the numerator, we are just extracting the deviation that we just explained. So for example, there is an average which is represented by the line and the average. So if you see, whatever these points are representing their average sales price for that particular in that color for a company. So we are getting that average sales price. So that would be the value for this point, and we are getting window average of all the average of all these points. So window average means for each of the line, each of the colors, we'll get the average. So that will give us this line value. So we're taking a difference between that, and we're also calculating the what is the standard difference, standard deviation for this sample set of values. So that is the normal definition of z-score. So it's
so this is basically that x minus mu by sigma. That it's the same formula, right?
Exactly.
X is average, minus mu is the window average, divided by sigma is the window standard deviation.
Correct. Yeah. So x is the value, sample value that we are looking at. In this case, it happened to be average, but it need not be average here. But the mean that we are trying to look where the deviation from has to be average of the values. So let me click OK. So that will give us our z-score, and let me just duplicate the sheet and remove this sales price and place my z-score here. Let me export. So okay, so now here let me, so yeah, earlier I used to have sales price, and the reason why I swapped that with z-score I'll explain in a minute. So first, before that, let me just format a couple of things. So lines, zero lines. So what this line is representing is line of z-score is equal to 0. Okay, and what it means is basically, if you see in this particular graph, in this particular view where we are looking at average for each and every color. So the average, obviously they don't it's not necessary that the average for each color has to be same equal to the average for each of other colors, right? So that's why we're getting this zigzag pattern for these averages, and we are looking at absolute differences. But when we change this to z-score combination, all this means will fall under one single line. So that is why we called earlier, for wherever if the value is equal to mean of it, the z-score for that would be 0. So all those means are falling on single line, and now likewise we are getting all these various points in terms of basically we are seeing the deviations of all those points in terms of z-score now. So if you see here, set the table calculation scope first. So because it involves window sum and window all, so I'll have to arrange the table calculation. So I'll have to get for every color, I need to calculate my windows across those different companies. So I'll set it up like that. And I have in my previous sheet, I have something called, let's look at Aston Martin. Aston Martin is my top selling with the average sales value of 78,000, which is above the topmost, above the mean value. So if you see the same Aston Martin, that value that we saw there, it's 2.3 standard deviations greater than the mean value, and likewise. So here it will basically, what it's supposed to give you is show a quick analysis of how each of your companies are varying in terms of prices with respect to averages in those colors. So if I select BMW, so that is how it's deviating from all the average prices. So if I select Aston Martin, so what it means is, hey, in this particular color, Aston Martin is selling way higher than the average price that is allowed, and whereas in these colors, Aston Martin is selling very close but less than the average price that is sold by when compared to all other cars. So that's what the analysis is supposed to drive using this. They also call it standardized score just because we are standardizing all these deviations from into one particular measure in terms of deviation. Any questions in this part? The first part we'll come back to that again.
It looks really good when you highlight something, Jagdish, so that all the dots, it sort of makes it very interesting to read.
Yeah.
Right? Yeah.
Okay.